Hello everyone, so welcome back. Today we'll be going over examples when it comes to classifying numbers and types of numbers. Always remember when you are classifying your numbers that if it is a natural number, then it's a whole number. If it's a whole number, it's an integer. If your number is an integer, it is also a rational number. And then we have our irrational here on the side. Then always remember that all these numbers are real numbers. Now, as I mentioned in my previous video, we do have complex numbers and imaginary numbers, but those are going to be done in separate videos, okay? So first example we have is -3. Is -3 a natural number? It is not a natural number. Is -3 a whole number? No, it's not a whole number. Is -3 an integer? Yes, it is an integer. Is -3 a rational number? Yes, it is, because -3 can be written as a fraction or a ratio. I can turn -3 into a fraction with an imaginary 1 under. And is -3 a real number? Yes, it is. What about 4.5 with a line over the 5, where this means 4.5555, and it keeps going on and on and on. Is this number a natural number? No, it is not natural. Is it a whole number? No, it is not a whole number. Is it an integer? No, not an integer. Is 4.5 repeating a rational number? Yes, it is rational. It's not irrational. And is it a real number? Yes, it is. So 4.555 repeating is rational and real. What about 4.5319876609? On and on and on. Is this number 4.5319876609 a natural number? Nope. Is this number a whole number? No, not a whole number. Integer? Nope. Rational number? No. What about irrational? Yes. And is it a real number? Yes, it is. So this number is classified as an irrational number and real. What about the number 1? Is the number 1 a natural number? Yes, it is. Is the number 1 a whole number? Yes. If it's a natural number, it's a whole number. Is number 1 integer? Yes. Is it a rational number? Yes, it is. It's not irrational. And is it a real number? Yes, it is. So the number 1 is natural, whole, integer, rational, and real. What about the square root of 5? Is the square root of 5 natural? No. Is it a whole number? No. Is it an integer? Nope. Rational? Nope. And what about irrational? Yes, the square root of 5 is irrational because I cannot write the square root of 5 into a fraction or a ratio. And is the square root of 5 real? Yes, it is. So the square root of 5 is classified as irrational and real. What about 5.632, and the 632 is repeating? So 5.632 is 5.632632, repeating on and on and on. Is 5.632 a natural number? No. Is it a whole number? Nope. Integer? Nope. Rational number? Yes. And is it a real number? Yes. And what makes it a rational number is because this decimal is repeating. What about -12 over 4? I can simplify -12 over 4 to a -3. So technically, we are addressing this -3 here. -3, is -3 a natural number? No. Whole number? No. Integer? Yes. Rational number? Yes. And is it a real number? Yes. So -3 or -12 over 4 is integer, rational, and real. What about the cubed root of 40? Is the cubed root of 40 natural? Nope. Is it a whole number? It is not a whole number. Integer? No. Rational? No. What about irrational? Yes. And is it a real number? Yes. So the cubed root of 40 is irrational and real. What about negative 1.07? Negative 1.07, is it a natural number? No. Whole number? No. Integer? No. Rational number? Yes, because it's a terminating decimal. It's not irrational. And is it a real number? Yes. So negative 1.07 is rational and real. So what if I gave you a set of numbers? So we have negative 3, 4 over 3, 0.12, square root of 2, pi, the number 10, and then we have a decimal, 2.1515 repeating. So let's start with the first one. Negative 3, is that a natural number? No. 4 over 3, is 4 over 3 natural? No. 0.12, not a natural number. The square root of 2, no. What about pi? Not a natural number. What about the number 10? The number 10 is a natural number, so I'm going to write 10 there. And then what about 2.1515 repeating? That is also not a natural number. And I'm going to write whole here because number 10 is also a whole number. So let's look for the integers now. Negative 3, is negative 3 an integer? Yes, it is. I'm going to write negative 3. What about 4 over 3? No, not an integer. What about 0.12? Not an integer. The square root of 2, not an integer. What about pi? Nope. What about the number 10? The number 10 is an integer. And what about 2.1515 repeating? This decimal here is not an integer. So the only two integers that we do have in this set is negative 3 and 10. What about rational numbers? So negative 3 is a rational number. 4 over 3 is rational. 0.12 is also rational. What about the square root of 2? No, it's not a rational number. Pi is not a rational number. What about the number 10? 10 is rational. And then what about 2.151515? That number is also rational because I do have a repeating decimal. What about irrational? The square root of 2 is irrational, so I'm going to write square root of 2 here. And then what about pi? Pi is also irrational. So what are the real numbers? And the real numbers here are all of the numbers. So all of the above are real numbers. Okay, let's look at this set here. So we have 7 over 8, negative 7, negative 2.888, 3 pi, 9, and 7. So let's find the natural numbers. 7 over 8, is that a natural number? No, it is not. Negative 7, nope. Negative 2.888, also not a natural number. What about 3 pi? No. What about the number 9? Yes, the number 9 is a natural number. And then what about the number 7? The number 7 is also a natural number. And 9 and 7 are also whole numbers. So let's find the integers. 7 over 8 is not an integer. What about negative 7? Yes, negative 7 is an integer. So 2.888, even though this is a negative number, 2.888 is not a whole number. So this is not an integer. What about 3 pi? No. What about the number 9? Yes, 9 is an integer. And then what about the number 7? Yes, the number 7 is also an integer. So let's look at the rational numbers. 7 over 8. Is 7 over 8 a rational number? Yes. What about negative 7? Yes. What about negative 2.88 repeating? Yes. What about 3 pi? No. What about the number 9? Yes. And then what about the number 7? Yes. Now let's look for irrational numbers. The only irrational number that we have in this set is going to be 3 pi. What are the real numbers? All of the numbers in this number set are real numbers. So all of the above. So let's try this number set here. We have 8, 3 over 4, the square root of 5, pi, 1, and then negative 9. Is 8 a natural number? Yes, it is. I'm going to write 8 here. 3 over 4, is that natural? No. The square root of 5, is that a natural number? No. What about pi? Nope. What about the number 1? 1 is a natural number. And then what about -9? -9 is not a natural number. And 8 and 1 are also whole numbers as well. Okay, so now let's look for the integers. Is the number 8 an integer? Yes, it is. What about 3/4? No. What about the square root of 5? No. What about pi? Nope. What about the number 1? Yes, 1 is an integer. And then what about -9? Yes, -9 is also an integer. Now let's find the rational numbers. Is the number 8 rational? Yes, it is. 3/4? Yes. The square root of 5? No. Pi? No. The number 1? Yes. What about the number -9? Yes. And now let's look for irrational numbers. So the only two irrational numbers that we have is the square root of 5. So I'm going to put square root of 5 here, and pi. And then what are the real numbers here in this set? All of the numbers here in this set are real numbers. So that is all we have for today, and I will see you all in the next video. Bye guys.